Hello, welcome to your second video for AP Statistics. This is Sallette again, and we are going to talk about analyzing categorical data. Once you get your textbook, you will be able to see that this is in section 1.1, Analyzing Categorical Data. The essential question for today, what types of graphs are used to display categorical data? So yesterday we were introduced to categorical data and quantitative data. Today we're just going to be really talking about how we can organize and display categorical data. So for starters, remember that categorical variables is when we can place individuals into one of several different groups or categories. Typically it's not a numerical value. So what we can produce for these situations are called frequency tables, and this is just a way to arrange in a table the counts of individuals that lie into different categories. Another way that we can look at this is in terms of what's called a relative frequency table, and this is when we break them down into percentages that fall into the different categories. So that these two tables that you see are displaying the same information but in different ways in terms of the table format. So let's talk about the two popular ways that we can display categorical data. Let's talk about a bar graph. I know I mentioned this yesterday, but a bar graph compares quantities measured in the same unit. So that information that we just saw from the frequency table, here we have a bar graph of that same information placed in a bar graph. The only thing that I'm going to have a problem with in terms of this bar graph is the axes aren't labeled. The name is there, but we would want to know that this axis has to do with the counts and this has to do with the genre on the x-axis here. So other than that, this is a pretty good representation visually of the data that was in that chart. Second way that we can display categorical data is called a pie chart. And a pie chart, I know you've seen these before. This one, we use the relative frequency table in order to produce the pie chart. Why? Because in terms of percentages, that shows the data in relationship to a whole. So if we are talking about 100% of the radio stations here, these show each pie piece as percentages of that whole 100% of radio stations. So this is the circumstance in which it would make sense to use a pie chart. When you're looking for percentages of a whole. Whereas with the bar graph, you're just looking for counts and measures compared to one another in terms of counts in the same unit. Things to remember when graphing your data. The scale must be displayed in equal increments. So you can't just start counting by 2s on an axis and then all of a sudden start counting by 5s. That doesn't make any sense, and it really nullifies the validity of your graph. So you have to be consistent. When you're choosing the scale, you want to make sure that it goes all the way up through the largest amount that you're going to be displaying, as well as the smallest amount. So you have to use your judgment in terms of creating the scale for the circumstance. And one of the things that I was just complaining about in the previous graphs, label. You need to label the title of your graph, your graphic display, as well as the axes. What do they mean? What do they represent? And it may make sense to you, especially when it's right next to a table, but this is something, especially on the AP exam, that they will count off on in a heartbeat. Just you didn't label an axis. So label. When in doubt, label some more. Alright, so births are not as you might think evenly distributed across the days of the week. So here's the average of babies that were born each day of the week in 2003. As you see, in terms of creating this bar graph, I am counting births in the thousands here. So 3,000, 6,000, 9,000, 12, and I'm counting by 3. So I'm consistent with my numbering, and I've labeled it as births in thousands. And on the x-axis, I have my days of the week: Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Now, I also gave my graph a title: 2003 births by day of the week. Probably we should have said average births by day. That would probably clarify this graph a little bit more. But we used this table over here, and that's what we produced. Hopefully you're able to produce something very similar to that. What are some of the possible reasons why there are fewer births on weekends? This is something that we are using statistics. This is the purpose of statistics, is to find out the whys. Sunday and Saturday. Sunday especially is low, but Saturday is pretty low. Why could this possibly be so? Well, doctors, just like the rest of us, don't necessarily like to work on weekends. And so in terms of scheduling of inductions, which is a popular way to do birth these days, they're not scheduling them on weekends. So the ones that are the births that are happening on Saturday and Sunday are most likely emergency and or standard procedure without being scheduled. Okay. Of the following table displays the percent of 15 to 18-year-olds who own the following personal media devices, according to the Kaiser Family Foundation. Okay, so here we have the device that's listed and the percent of students or teenagers that own them. Make a bar graph to display the data. Okay, here's a bar graph that you could have made. On the y-axis, we have the percentages who owned which devices, and on the x-axis, we have the devices. Name of it is Media Devices Owned According to the Kaiser Family Foundation. We could probably add that it's by 15 to 18-year-olds. I want you to notice something about the percentages, though. Just because you own a cell phone doesn't mean that you cannot also own an MP3 player, a handheld video game player, a laptop, a portable CD or tape player. So just because you own one doesn't mean you can't also own another. That's why these percentages, they don't add up to 100%. They add up to well over. So that leads me into B. Would it be appropriate to make a pie chart for these data? Why or why not? Well, no, not for this data, because since they don't add up to 100%, then it doesn't make sense for us to make a picture of them out of a whole 100%. We are talking about more than a whole. You can own more of one device than another. A Venn diagram would display this, but not necessarily display in terms of numbers the type of information that we can display in a bar graph right here. So the bar graph would be the best choice for this situation. I want you to look at this DirecTV advertisement. It has problems in terms of mathematical representation. Why? Because they're advertising their company, and of course they're going to try to draw your eye to their product. That doesn't mean that they are following the rules in terms of graphical representation. This is what we call a graphic in the math world. This is not a graph. A graphic is more accurate of a description. Why? Well, whenever we're talking about a bar graph, first of all, we have our axes labeled. Not here, not so here. And the heights and widths have meaning. So when I'm talking about a bar graph like the one that we made earlier, the width of each bar is the same. When you change the width, your eye is being drawn to it as having more weight. And so in order to have the height mean something, the width needs to be consistent and the same. Secondly, since the widths are not the same, your eye, of course, is drawn to the giant 95 DirecTV HD channels. And 81, is it that much smaller than 95? What about 56? It's not even that much smaller than 81. So why are these two so small? Well, that's because this is an advertisement for DirecTV. Secondly, the size of the numbers here is also representative of the value that it's supposed to display whenever you're presenting a graph correctly. So here we have a giant 95 and a much smaller 81 and an even smaller 56. And in terms of scale, they did not get equal treatment in terms of, is 56 large enough to represent 56 in comparison to 95. So this advertisement has several problems in terms of actually being a good math representation of DirecTV versus Dish Network and cable. You could make an appropriate bar graph that would show the DirecTV having 95 HD channels, Dish Network having 81, and cable having 56. So you could make this a legitimate bar graph, but it would not look like this for the reasons that I've mentioned. So that concludes today's notes, and I look forward to seeing you in class tomorrow. If you have any questions, make sure to write them down at the bottom of your note guide, and we will talk about them tomorrow. See you tomorrow.